All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. Please let me know in the chats if I'm perfectly audible and visible to each and every single student. Okay? All right, people. Yo. So, guys, welcome to this beautiful session. We have got over here. That is we say kinematics. That is we say kinematics. We have got part two. We have got kinematics part two over here. Just a second. Let me fix up this camera over here. Okay. So, guys, in the today's session, we will be exactly talking about. So in the today's session, we will be exactly talking about that is nothing but we have got few topics that we need to discuss in the today's session, and that is we say speed, that is we say velocity, and that is we say acceleration. So these are the topics that we have to study in the today's class. So I would want everybody of you to call up your friends, okay, so that we can start our session, and most importantly, every single thing I will be starting from the scratch. Every single thing I will be starting from the basics. If you haven't studied any of these topics before, I guarantee you, you would be able to understand each and every single point. That is my guarantee. That's for sure you are going to understand it. Okay. So my dear friends, everybody, and make sure you hit the like button, because liking the session is extremely mandatory. I would want you guys to hit the like button, everybody out there, so that we can start our session over here. Okay. So guys, now let's basically move on. Let's basically move on to the first question that we have got on the screen. Previously, when it comes to the distance and the displacement, I have clearly explained what is distance and I have clearly explained what is displacement. Okay. Now, in this particular question, we will have to solve some of the questions over here. Now, in this particular question, the question says that find the displacement between A and B. Guys, see. Over here, there was a particle which started its motion from A point. Okay. There was a particle which started its motion from A point, and then it moved something like this, and finally reached point B. And in this particular case, you guys are supposed to find out, what is the total distance covered by the particle in this particular case. Sir, when it comes to the total distance covered, listen to me very carefully. We say, sir, total distance covered. Sir, total distance or distance covered is basically the actual path traveled. Sir, how much path it has actually covered? Sir, this is 4 meters, this is 7 meters, and this is also 7 meters, and this is also 7 meters. So can I say this is 7 plus 7 is 14. 14 plus 4 plus 3, and it comes out to be, we say, sir, 21 meters. So the actual path covered by the particle is something like this, That is 4 plus 7 plus 7 plus 3. But when it comes to the displacement, my dear friends, can I say displacement is basically the distance between the initial point and the final point. How much particle has actually displaced? So that is this much only, because this is the initial point, this is the final point. Now guys, see, if we take a look, this is a square. If this side is 7, don't you think that this side over here, if we complete this side over here, sir, this side will be also 7 meters? And This is given as 4 over here. Can I say this will be in that case, sir, 3 meters, this portion? Yes. Now, from the bottom also, we say, sir, this will be also, we say, sir, 7 over here in the from the bottom. If this is 7, this distance will be also 7. This is given as 3. So obviously this will be given as 4 meters. Now guys, look at this particular triangle. Look at this particular triangle. You have to find this distance. Let me basically take out this triangle over here. Let me take out this triangle over here. I'll make it something like this. I'll make it something like this. So guys, in this particular case, this is 3 meters and this is 4 meters. And we are supposed to find this hypotenuse of this particular triangle. Can I say, sir, when it comes to this hypotenuse, sir, hypotenuse will be equal to under root of, use PGT. That will be 3 square plus 4 square. That will be simply 3 square plus, we say, sir, 4 square. So can I say, sir, this hypotenuse in this case will come out to be 3 square is 9, 4 square is 16, 16 plus 9 is 25, that is under root 25, and that will come out to be 5. So means this distance is coming out to be 5 in this particular case. So can I say over here, we say displacement is simply that is 5 meters. Guys, is this clear? Please tell me in the chats. Everyone means everyone. I just need the signal from every single student that if this is crystal and clear. If this is crystal and clear, let me know in the chats. Let me know in the chats. Everybody out there, guys. Is this crystal and clear? Is this crystal and clear? Okay. Great. Okay. So we say displacement in this cases, we say, sir, that is 5 meters. Now guys, let's suppose if we have got a question something like this. If the position of an object is x is equal to t square plus 2t plus 4. Now here, the position of an object is changing with respect to time. Let's suppose this is an object, it is moving, okay? And its position is given as x is equal to, we say, sir, t square plus 2t plus 4. Sir, why isn't the position of the particle over here given as x is equal to 10 meters, 20 meters, something like that? We say it is changing with time. Like at t is equal to 1, put t is equal to 1 over here, position will be 1 plus 2 plus 4, that will be 7 meters. So at time t is equal to 2, you have to put the time t is equal to 2 over here. Now, it says that find the displacement in 4 seconds and find the displacement in 4th second. Guys, see, let's suppose we have got a particle over here and this particle is moving. And it has reached this particular position. So guys, understand one thing very carefully over here. I say, let's suppose at t is equal to 1 seconds, particle was here. At t is equal to 2 seconds, particle was here. At t is equal to 3 seconds, particle was here. At t is equal to 4 seconds, particle is exactly here. So we have to find this displacement in 4 seconds. Guys, see, how do we find the displacement? Understand one thing. Can we find, listen to me very carefully. If position time relation is given and you guys are supposed to find the displacement, see, first we'll find, we say position of a particle at t is equal to, we say, sir, 0 seconds. At t is equal to 0 seconds. That is what we call the initial position. If we get this position at t is equal to 0 seconds, and then if we get final position at t is equal to 4 seconds, we can find this displacement. I'll show you. Sir, at t is equal to 0 seconds where the particle is standing, so put t is equal to 0 over here. So we say x is equal to, so this will be 0 square plus 2 into 0 plus we say sir 4. So x will come out to be over here, that is 4. So when time was 0, position of the particle in that case was, we say 4 meters. Position in that case was 4 meters. Now guys, understand one thing. Let's suppose I say position, we say position of a particle, position of a particle at t is equal to 4 seconds. Guys, if you remember the last class, I have told you when it comes to the displacement is always equal to final position minus initial position. Initial position we got as 4 meters. Now we have to find the final position. See how I'll make you understand. So we say put t is equal to 4 over here. We say sir x is equal to, so this will be t square, that is 4 square is we say sir 16 plus, then 2 into 4, that is we say sir 8. Then we say this plus 4, this plus 4. So we say 16 plus 8 is 24. 24 plus 4 is, we say sir 28. So x final in this case is coming out to be 28 meters. Guys. So means at t is equal to 0, the particle is here. At t is equal to 4 seconds, the particle is here. What is the position? 28 meters. Now, how much is this displacement? Guys, see, when it comes to the displacement, I'll write over here, displacement is, sir, final position. What is the final position? 28 meters. This is 28 minus, what is the initial position? That is 4 meters. You say, sir, 4. So this comes out to be 24 meters. So means the displacement of the particle in 4 seconds is, we say 24 meters. We say 24 meters. Is this crystalline clear? Please let me know in the chats. Please let me know in the chats. Guys, let me know in the chats if this is crystal and clear. If this is crystal and clear. Everyone means everyone. Guys, tell me in the chats if this is crystal and clear. I want everybody. Yes, great. Okay, great. Now, what we are supposed to do is we have to find the displacement. We have to find the displacement in, we say, sir, 4th second. Guys, see. Let me make you understand. Let me make you understand over here. Let's suppose the car started from this point and it reached, we say, sir, this point. Guys, see. I say at t is equal to 1 seconds, the car was here. At t is equal to 2 seconds, the car was here. At t is equal to 3 seconds, the car was here. At t is equal to 4 seconds, the car is here. Guys, see. Let me just tell you, sir, can I say this is the displacement of the car in first second? Yes, sir. Can I say this is the displacement of the car in second? Yes, sir. Can I say this is the displacement of the car in 3rd second? Can I say this is the displacement of the car in 4th second? Yes, sir. So we have to find this displacement. We have to find this displacement over here. Guys, see. If we get the position of the particle over here, if we get the position of the particle at t is equal to 3 seconds, and if we get the position of the particle at t is equal to 4 seconds, so what we will do? Sir, final position minus initial position, we will get this displacement. Guys, see. What I'll do is that, I say position of the particle, at t is equal to 3 seconds. What is the position of the particle at t is equal to 3 seconds? Guys, see, take this equation, put t is equal to 3 over here. So I'll say, sir, this will be x is equal to t square, x is equal to t square plus 2t plus 4. We say plus 2t, we say plus 4. Now put t is equal to 3 seconds over here. So I say x will come out to be, that is 3 square is 9. So this is 9 plus 2 into 3 is 6 plus, we say, sir, 4. Now 9 plus 6 is 15. 15 plus 4 is 19. So we say x will come out to be, this is x initial. This will come out to be 19 meters. So now guys, at t is equal to 3 seconds, particle is at what distance? Particle is at what distance? Guys, see, at t is equal to 3 seconds, particle is at what distance? We say, sir, this is over here 19 meters. And we already know that, at we say t is equal to 4 seconds. We say, sir, x final, that we already got in the last one, at t is equal to 4 seconds, we say position is 28 meters. That is 28 meters. So we say here, it is 28 meters position. This is the position, guys. Now, if you have to find this displacement, what will you do? 28 minus 19. So we say displacement in fourth second. So can I say that will be S is equal to, so that will be 28 minus, we say, 19, and that will come out to be 9 meters. Do you all agree with me? Is this crystalline clear? Please tell me in the chats. Is this crystalline clear, guys? So this was the displacement in the fourth second, and previous one was the displacement in 4 seconds. Previous one was the displacement in 4 seconds. Okay. Guys, give me the signal in the chats if everything is crystalline clear and sorted. Cool. Now, this is the question that we have exactly over here, and I would want you guys to solve this particular question from your end. Your end only, Okay. If the initial position of an object is 2, 6, 9, these are the coordinates of an object. Okay. And then the final position is 8, 12, minus 12, we say, sir, 19. Okay. Now, my dear friends, we say there is a particle over here. There is a particle exactly over here. Its coordinates are, this is the initial position. Its coordinates are 2, 6, and we say, sir, 19. And finally, let's suppose the particle reached over here, and we say its coordinates are, we say 8, we say, sir, minus 12, and we say, sir, 19. Can you tell me how much it has displaced? We say, sir, it has displaced, let's suppose, by this much amount. These are its initial coordinates. Sir, what does this mean? Means in x, its value is 2. In y, its value is 6. In z, its value is 19. 8 minus 12 and 19. 8 minus 12 and 19. Now, you guys are supposed to tell me this displacement. And I have already taught you guys the vectors previously. Okay. So, I am expecting that you guys will solve this question. So, I'll keep this as homework. Okay. I will show you this question in the next class, but I would want you guys to give it a shot once from your end. And do let me know the answer in the comments. Do let me know the answer of this question in the comments. Now guys, let's move on to basically the concept of speed. Let's move on to basically the concept of speed. What does the concept of speed actually say? What does it actually say? See guys, we say speed means how fast an object is covering the distance, or how fast an object is moving. How fast an object is moving. Guys, see. I say, let's suppose there is a car over here. Let's suppose I say there is a car over here. Let's suppose I say there is a car over here. Okay. And this car is moving, we say, with 20 kilometer per hour. Sir, what does it mean? It means how fast the car is moving. Like every hour, we say this car is covering how much distance? We say 20 kilometers. So we say every hour, car is covering 20 kilometers. Like if I say over here, I have got one more car over here. Okay. And this car is moving with, we say, sir, 100 kilometer per hour. What does this mean? Means every hour, we say car is covering 100 kilometers. Can I say this is moving more fastly? Yes, sir. Can I say its speed is more? Yes, sir. So that's what it is mentioned over here. How fast an object is covering the distance. How fast an object is moving. It is covering the distance very fastly, because in 1 hour it is covering 100 kilometers. In 1 hour it is covering only 20 kilometers. So this is what speed is all about. This is what speed is all about. Okay. So my dear friends, let me just tell you over here. When it comes to the speed, okay, we say speed is simply how fast an object is covering the distance. So we say distance upon, we say, sir, time. Distance upon time. This is, we say, sir, speed. Now guys, listen to me very carefully. If this is the speed, that is distance divided by time. Now my dear friends, we say this speed is a, we say, scalar quantity. Okay. And I say it does not have direction. It does not have direction. So this speed does not have direction. Speed does not tell you in which direction the car is moving. Speed only tells you how fast the car is moving. I say, let me mention this point also. We say speed does not tell us in which direction the car is moving. But it only tells us how fast the car is moving. It only tells us how fast the car is moving. That's why we say it's a scalar quantity, because it does not have the direction. Now guys, see. Now there are two types of speed. We say instantaneous speed, and then we have the next one as average speed. Okay. Guys, understand one thing very carefully. Let's suppose an object over here, an object is basically moving from this point to, we say, sir, this point. From point A to, we say, sir, point B. And in this particular case, I say it is covering this much of distance, and let's suppose this is delta D. D is what we call the distance over here. Sir, this is the total distance covered by the object. Okay. And let's suppose it is taking the time as delta T. It is the total time delta T. Okay. My dear friends, if I ask you the simple question over here, sir, what was the speed of the car from A to B? Let's suppose instead of delta D, I'll write over here, we say, sir, 100 kilometers. And from A to B, time is, let's suppose, 10 hours. Let's suppose I am asking you, what is the speed of the car from A to B? You say, sir, when it comes to the speed over here, you say, total distance covered. How do we find distance by time? We say total distance covered, okay, and divided by, we say total time taken. This is how we find the speed. Now, how much is the total distance covered? That is 100 kilometers. How much is the total time? That is 10. This and this will cancel. So this will come out to be 10 kilometer per hour. So this is the speed. And this speed is what we call the average speed. This speed is what we call the average speed. Means this is telling you how much is the speed of the car from A to B in general. This does not tell you that the speed of the car at every point is same. And this is what we call the average speed. And if we write this, we can also write this average speed as, guys, see. Average speed means total distance covered. We can write this total distance covered as delta D also. Total time taken, we can also write this as delta T also. This is how we define the average speed. Total distance covered divided by total time taken, delta D by delta T. Okay. And this is the average speed from A to B. Okay. In general, what is the speed from A to B? That is what we call the average speed. Now, my dear friends, since we have to discuss about the instantaneous speed, understand one thing very carefully. Over here. Let me change the topic over here and I'll call this as average speed. Okay. So I'll mention over here that is average speed. So what was the speed from A to B in general? Now, let's suppose, my dear friends, if I ask you the question, when the car is basically moving from point A to basically point B, I am asking you, what was the speed of the car at this particular instant when the time was, let's suppose 10:30. I'm not asking you what was the speed of the car from A to B in general. No. What was the speed of the car at this particular instant? Now, I say the speed of the car, at any particular instant, is called, we say instantaneous. We say, sir, speed, instantaneous speed. Speed at any particular instant is called the instantaneous speed. Speed from A to B is what we call the average speed. And guys, see. If in case of average speed, you took the total distance as delta D, total time as delta T. So delta D is a bigger distance. Delta T is a bigger time. So can I say in this particular case, if you have to find the average speed, instantaneous speed, you take the distance covered in this instant. Will that be small or will that be large? So we say that is very small, and we say sir, DD, small distance. And here in how much time they have covered the small distance in very small time, that is DT. So can I say speed instantaneous? It is simply, I say small distance upon, we say, sir, small time. You can basically write it something like this, okay, in order to make you understand very carefully, very properly. So I can say this will be simply, that is dd divided by, we say, sir, dt. dd divided by, we say, sir, dt. This is basically the rate of change of distance with time at any particular instant. So this is what we call the instantaneous speed. Guys, tell me in the chats if this is crystalline clear to each and every single student. Tell me, guys. Everyone means everyone. I need the signal from every single student out there. Is this crystalline clear? Is this crystalline clear? Everyone means everyone, guys. Tell me, guys. Okay. Great, great. I hope instantaneous average speed is absolutely clear. Instantaneous speed and average speed is absolutely clear. So average speed is the speed in general from A point to B point. Instantaneous speed is the speed at any particular instant, Next, average speed is done, total distance traveled. Next, we have got the velocity. Velocity is important, guys. Velocity is important. See, when it comes to the velocity, we simply say velocity means it is how fast an object is moving and where. Guys, see. Let's suppose I give you the example over here. I have got a car. Okay. And this car is moving with a speed of, let's suppose it has got 20 meters per second. And I have got another car over here. Understand very carefully. This car is moving with a speed of, we say, sir, 20 meters per second. If I ask you over here, sir, this car A and this car B, what is similar in A and B? You'll say simply, sir, the speed of this car is equal to the speed of this car. We say speed of A is equal to, we say, sir, speed of B, because both are moving with 20 meters per second. So means they are moving with the same speed. But when it comes to the velocity, we say velocity of A is not equal to the velocity of B. Why, sir? Velocity means how fast the car is moving and towards where. This is moving towards left and this is moving towards right. So they have got the different direction. So that's the reason I am saying velocity of these two cars are not equal, because the direction is opposite. If I say this is car A, it is moving in the forward direction, and we say, sir, this is car B and it is also moving in the forward direction. This is moving with 20 meters per second. This is also moving with 20 meters per second. Now here I can say velocity of A is equal to velocity of B. Why? Because they have got the same direction. So I can say in this particular case, it is how fast an object is moving and towards where. Or along with the direction. Okay, along with the direction. So we can also say it is called the speed with direction. So 20 meter per second towards north. Speed with direction is what we call the velocity. So whenever you say velocity, so along with velocity you have to mention the direction also. You have to mention the direction also. Now guys, tell me one thing. If I have to define the velocity, okay, so we say in case of speed, you took the total distance traveled upon total time taken, distance upon time. When velocity is a vector quantity, don't you think that we should take, sir, displacement divided by, we say, sir, time? Why? Because displacement is a vector quantity. Displacement has got a proper direction. So if displacement has got proper direction, means velocity will be having the proper direction. So that's why in case of velocity, you write displacement. In case of speed, you write distance upon time. Next. And when it comes to the SI unit, we say, sir, SI unit over here is, see guys, what is the SI unit of displacement? We say, sir, we measure it in meters and time in seconds. So that will be simply meter per second. Now guys, understand very carefully. What is instantaneous velocity? Like you are having instantaneous speed and instantaneous average speed, here you have got instantaneous velocity and average velocity. Guys, see, I say it is the velocity of an object at any particular instant. It is the velocity of an object at any particular instant. And when it comes to the instantaneous velocity, we write it something like this. That is, sir, simply that is ds divided by dt. That is small change in displacement upon small change in small change in displacement upon small change in time. Is this clear, guys? Is this crystalline clear till over here? Let me know. And what is this? This is also we called as differentiation of displacement with respect to time. This is also the differentiation of displacement with respect to the time. This is also the differentiation of displacement with respect to the time. Okay. Now guys, we have some questions. Like guys, if previously I have told you what is this dy by dx? Dy by dx is small change in y upon small change in x. Or we say differentiation of y with respect to, we say, sir, x. So simply from now onwards, you'll remember that if displacement is given and they ask you to find the instantaneous velocity, what will you do? You will do differentiation. So if differentiation, so if displacement of a car is given, to find its instantaneous velocity, we differentiate. So remember this, my dear friends. If from now onwards displacement of an object is given and you guys are supposed to find the instantaneous velocity, you do the differentiation. Now guys, let's talk about this particular question. Let's talk about this particular question. We say over here, if the position of an object is given something like this, then find the instant. Okay, before this, let me just tell you, let me show you the simple question over here. Let me show you the simple question. If the displacement of an object is s is equal to t square plus 2t plus 1, find the velocity at t is equal to, we say sir, 4 seconds. We are supposed to find the velocity at t is equal to 4 seconds. Okay. Tell me guys. Guys, see. In this particular question, we said displacement of an object is given. And we are supposed to find the velocity. Now, can I say, as we know, we say, sir, velocity is simply, that is ds divided by dt. That is differentiation of displacement. Okay. So I can say v is equal to, that is d by ds of this, sorry, d by dt of this. That is d by dt of this s. Now, what is the differentiation of this? Sir, differentiation of t square will be simply, that is 2t. How, sir? Power down, power minus 1. So 2 down, 2 minus 1 is 1. Then plus differentiation of 2t is, we say, sir, 2. Then plus differentiation of constant is 0. Now we say at t is equal to, we say, sir, 4 seconds. So I say velocity will be 2 into 4, we say, sir, plus 2. So now 2 into 4 in this particular cases, we say, sir, this will be 8 plus 2, and that is, we say, sir, 10 meter per second. Is this clear, guys? Is this clear? So this is how we find the velocity of an object if its displacement is given. Now guys, see, let's move on to the next question. The question says that if the position of an object is given something like this, then find the instant when velocity becomes 0. Okay. Let's first find till over here when velocity becomes 0. Guys, see. I will make you understand certain things over here. We say as x is given as x is equal to, we say, sir, t square minus 4t, we say, sir, plus 5. So position time relation is given, means a car is moving according to this relation. And we have to find, let's first find velocity. Velocity is simply, that is dx divided by dt. And that will be simply, we say, sir, for t square it is 2t. Then we say minus 4. 2t minus 4. This is, for 4t differentiation is 4. For 5 differentiation is 0. Now guys, it says that find the instant when velocity becomes 0. You have to find the time when velocity becomes 0. So I say put velocity is equal to 0 and get the time or find the time. So if I put velocity is equal to 0, that is 2t minus 4 is equal to 0. So can I say this 2t is equal to 4, 2 ones, 2 twos. Okay, so t will be equal to 2 seconds. So can I say now? We say at t is equal to 2 seconds, we say velocity of object is 0. Let me show you how. If we put t is equal to 2 over here, 2 into 2 is 4, 4 minus 4 is 0. So means this is the instant, this is the time when velocity of an object is 0, when velocity becomes 0, when object comes to rest. Now. Then further the question says that, and find the displacement when object comes to rest. Guys. Now, find displacement when velocity is equal to 0. Why? Because they are saying that find the displacement when we say object comes to rest. Find displacement when object comes to rest. Now guys, in this particular case, this is given as the position time relation. This is given as the position time relation. From this position time relation, you guys are supposed to find the displacement when object comes to rest. Guys, simple. Time t is given over here. I have shown you the similar type of question if you remember over here. Here, I'm not going to repeat the question once again. Here, this. Position time relation was given and you were supposed to find the displacement in 4 seconds and displacement in 4th second. Here in the question they are saying that, you have to find the displacement when time t is equal to 2 seconds. So now find the displacement when velocity is 0, that is time t is equal to 2 seconds. So now you have to find the displacement in 2 seconds, and this you guys are supposed to do by yourself only, because I have already shown you a question on this one. Guys, tell me, is this crystalline clear? Let me know in the chats if this is crystalline clear. Everyone means everyone out there. Is this crystalline clear? Everyone, guys. Is this clear? Is this clear? Great. Now you can do this by yourself only. Do by yourself only. Okay. Answer in this case is -4 meters. Answer in this case is -4. See guys, you have to basically find the displacement when velocity is 0. Velocity is 0 at t is equal to 2 seconds. Understand very carefully. Guys, see. You have to basically find the displacement from 0 to 2 seconds. That is, find the displacement from 0 to 2 seconds. How can you find that? Sir, displacement is, we say, sir, x final minus x initial. X final is the position when time t is equal to 2. X initial is the position when time t is equal to 0. Okay, so we say at t is equal to 0 seconds. Can you tell me what is the position? Sir, we say x initial will come out to be simply, this is 0 minus 4 into 0, and it will come out to be, that is 5 meters. We say at t is equal to 2 seconds. You guys are supposed to tell me at t is equal to 2 seconds. You guys are supposed to tell me at t is equal to 2 seconds. You guys are supposed to tell me, we say, sir, final, x final. So that is 2 square. We say, sir, 2 square minus, we say 4 into 2. Then we say plus 5. Now this will be how much? 4 into 2 is 8. 2 square is 4, 5. So this will come out to be 9 minus 8 is equal to 1. Now tell me displacement. Sir, displacement in 2 seconds will be simply, that is final minus initial. Final is 1 minus 5. That will come out to be minus 4 meters. This is the displacement. Is this clear? Is this clear? Yes. Next, let's move on to this question. Position of an object is given as a function of time. X is equal to t square minus 2t plus 4. Find the velocity at t is equal to 2 seconds. Find the velocity at t is equal to 2 seconds. Okay. And find the time when object comes to rest. As in this particular case, we say x is equal to t square minus 2t, we say plus 4. X is equal to t square minus 2t plus 4. Now we have to find the velocity at t is equal to 2 seconds. So velocity will be simply that is dx divided by dt. Now that is differentiation of velocity, this position. So that is, this will be 2t minus 2. Okay. Now at t is equal to 2 seconds, I can say at t is equal to 2 seconds, I can say velocity will be simply that is dx divided by, that is simply that is v is equal to 2 into, here we'll put 2 minus 2. So v will come out to be 2 into 2 is 4, 4 minus 2 is, which is a 2 meter per second. 2 meter per second. Next. So at t is equal to 2 seconds, velocity is 2 meter per second. Next. What is next over here? Guys, see. I say, sir, find the time when object comes to rest. Sir, when object comes to rest, don't you think that its velocity is 0? So we say, put velocity is equal to 0 and find the time. So this is the value of velocity. V is equal to 2 into, we say sir 2t minus 2 is equal to 0. So we say 2t is equal to 2. So t will be equal to 1 seconds. So at t is equal to 1 seconds, object will come to a rest. Okay. Is this clear? Please give me the signal in the chats. Everyone means everyone. Please give me the signal in the chats. Guys, let me know in the chats if this is crystalline clear to each and every single student. And guys, most importantly, if you have not liked the session yet, I would want you guys to hit the like button as soon as possible. Okay. Hit the like button as soon as possible. Next. X is equal to t square plus 4t plus 10. Find the time when object comes to rest. This is an interesting question. Guys, see here, x is equal to, we say t square plus 4t plus 10. Okay. And we have to find the time when object comes to rest. First, find the velocity. Velocity is, we say sir 2t. Velocity is, we say sir, differentiation of this one, that is 2t plus, we say sir 4. 2t plus, we say sir 4. Now I say put velocity is equal to 0. If you put velocity is equal to 0, don't you think that sir, this will be 2t plus 4 is equal to 0? Sir, 2t is equal to minus 4, 2 1s, 2 2s. So t will come out to be minus 2. Guys, tell me one thing. Do you think that time can be negative? So we say time cannot be negative. Time cannot be negative. So object, so which means object will never come to rest. rest, which means object will never ever come to rest. So if value of time is coming out to be negative, that means object will keep on moving forever and it will never come to rest. It will never come to rest. Okay. One more thing I just want to mention over here, my dear friends. What is that? What is that? See. We say as velocity is ds divided by dt. Velocity is differentiation of displacement divided by time. Now, if we multiply this over here, we say, sir, ds will come out to be, that is v dt. Okay. Now I am saying that integrate both sides. Now I am saying that integrate both sides. If you do the integration on both sides, this will be integration of ds is equal to integration of v dt. Now what is this integration of ds? So integration of ds, it will give you the total displacement, that is s. This will be integration of v dt. I would want you guys to keep this in your box. So what does this equation actually say? What does this equation actually say? This equation says that we say if velocity is given, to find the displacement, we integrate. If velocity is given, to find the displacement, what do we actually do? We do the integration. We integrate simply over here. Like, let me take out the question over here. Guys, if displacement is given and we are supposed to find the velocity, what do? We differentiate. And if velocity is given and if displacement is given to find velocity, we differentiate. If velocity is given to find the displacement, we integrate. Like if an object is moving with a velocity, let's suppose we have got an object over here. This object is moving with v is equal to 3t square. Then find the displacement in 2 seconds. We are supposed to find the value of displacement in 2 seconds. Guys, see, as I can simply say in this particular case, velocity is given, we have to find the displacement. So can I say displacement will be simply integration of, that is v dt? Yes. So we said displacement is integration of. What is the value of v? V is 3t square. So I'll put over here, that is 3t square, and this will be dt. Now you have to find the displacement from where to where. So that is from 0 to 2 seconds, because in 2 seconds we have to find it. So can I say this will be simply, now guys, take this 3 out, then integration of t square, and then it will be dt. And we can say this is 3. Integration of t square will be simply, that is t cube divided by 3. Why? Because if we say we have x, integration of x dx, we say integration of x will be simply x square by 2. Same is the case over here. This will be simply, that is power, x raised power. What is the power of x? 1. So that is 1 plus 1 upon 1 plus 1. So that is x square divided by 2. Now same over here, 3 and 3 will cancel. So I can say displacement will be, and the limits are from 0 to 2. So that is simply, so we say this is t cube and this is from 0 to 2. Now guys, we put the upper limit, then we put the lower limit. So s is equal to, upper limit will be, sir, 2 cube minus lower limit. Now first you have to put 2 in t, then you have to put 0 in t. So 2 cube minus 0. So s will be 2 into 2 into 2. That is, we say, sir, 8. So displacement would be in this particular case 8. Guys, is this clear? Please tell me in the chats. Please tell me in the chats, guys. So guys, let me just tell you something. Let me just tell you something. And what is that? What is that? See. I say that Unacademy's Plus subscription, if you haven't enrolled in any of the batches, let me just tell you, Unacademy's Plus subscription is right now only at 4,999 rupees. Okay? And with this Plus subscription, you can have the access to all the batches, whatever is running inside the Unacademy. And one more thing, guys, if you have not liked the session yet, I would want you guys to like it as soon as possible. Okay? So we say this is the lowest ever prices in all NEET UG subscription. Okay? So guys, so Unacademy's Plus subscription is right now only for 4,999. So if you want to buy it, if you want to enroll in any of the batches, join it as soon as possible, because this is only from July 18 to, we say, sir, July 25. July 25. Next, guys, there is a Phoenix Pro batch. This Phoenix Pro batch, this is starting from 26th of July onwards. And in this batch, we are completing the entire syllabus. This is for NEET 2025 droppers. So guys, enroll in this one at just 4,999. Okay, at just 4,999. I would want you guys to enroll and do not miss out any of the live classes over there. The link is in the description of this video. So click on to that link, and most importantly, we have got Unacademy Pro. Now, there are 3 versions of subscription. The first one is Plus, second one is Iconic, and third one is Pro. Sir, what is the difference between Plus, Iconic, and Pro? This is the difference. You can clearly see over here. Now you can basically, if you take the Pro, Unacademy Pro, in Unacademy Pro, you'll be getting the offline doubt solving also. If there is a nearby center to you, which is Unacademy Center, and you are having Unacademy Pro, you can clear your doubts with the help of the teachers over there in the offline center also. You can give the test series in the offline classes also. This is the difference between Iconic and Pro. This is the difference between Plus and Pro. Okay, so you can join any of these, my dear friends. Okay, so that's all for today. So thank you so much, my dear friends. Take care and bye-bye. See you guys in the next session. So most probably we'll be taking their sessions regularly. So take care and bye-bye. Okay, thank you.